Welcome to our MSci 555 project presentation. We will be optimizing the Premier League schedule. Let's start with project objectives. As outlined in the course syllabus, we will be applying the principles and topics covered in our course and other courses to a real-world problem, the English Premier League scheduling. By analyzing the scheduling of matches, we aim to further develop our analytical, research, and critical thinking skills. Finally, this presentation will help us develop our presentation and interpersonal skills. This is the table of contents. We will start with identify, where we will be identifying the topic we wish to investigate. Next, we will cover document, where we document how scheduling is currently done. Next, we will cover analyze, where we will cover what we learned to describe and improve this in the future. Finally, we will suggest, where we will be suggesting improvements for the topic. Identify. Let's begin by identifying the topic we will investigate. A problem background. The English Premier League is one of the most renowned football leagues worldwide. It generated over £5 billion in revenue over the 2021-2022 season. A SWOT analysis conducted in 2020 revealed that the Premier League's major strengths are the presence of global superstars, elite marketing, and a highly competitive league without weak teams. The scheduling of games in the league is a critical aspect that impacts several stakeholders, including football teams, players, owners, and fans. Thus, we have identified a method to address ongoing concerns and improve the quality of the league by optimizing its schedule. The proposed optimization method will have several benefits, such as minimizing travel time for teams, reducing fixture congestion, and ensuring that teams play a balanced number of home and away games. By reducing the burden on players, teams can perform at their best, resulting in a more competitive league and a better experience for fans. Scope for improvement. The Global Soccer's Players Union FIFPro recently conducted a study on the workload of football players in men's football. The study, which took place in late 2021, aimed to examine the impact of excessive back-to-back matches on players' well-being. The research found that there has been a significant increase in the number of excessive back-to-back matches in recent years. Excessive back-to-back matches refer to situations where players have fewer than 3 days to recovery time between matches. These matches can put immense strain on players, leading to fatigue and a higher risk of injury. Furthermore, the study revealed that a significant proportion of players reported feeling fatigued, both physically and mentally, as a result of excessive back-to-back matches. The increased workload and lack of recovery time can reduce the quality of play and increase the risk of injury, which can negatively impact players' careers and well-being. Scope for improvement. In the soccer sports science community, the red zone refers to a period where players are at a very high risk of injury due to accumulated fatigue. This period can be particularly challenging for professional soccer players, as they travel intensively and play multiple games a week. Playing in this zone can result in a player being at a higher risk of muscular injuries, such as strains and tears. Additionally, it can lead to mental and physical stresses, such as fatigue, stress, and decreased performance. Unfortunately, the issue of the red zone has been exacerbated by the COVID-19 pandemic, with many leagues scheduling more games to make up for losses. An example of this is the proposed UEFA Champions League reform, which would expand the number of games each team plays from 6 games in 10 weeks to 8 games in 10 weeks. The red zone is a significant concern for the soccer industry, as it poses a risk to the health and well-being of players.
The EPL has a number of stakeholders who benefit from our analysis. The players who benefit from our analysis as better scheduling will encourage a more balanced schedule, promoting enough rest time for players, and in terms of reducing the risk of injury and fatigue. The 20 clubs that compete in the league will benefit from our analysis, as better scheduling will allow for a more equal distribution of resources, thereby promoting a more level playing fields for all teams. The fans would benefit from our analysis as a more balanced schedule, and the fans will have a greater level of intensity as red zone attributed factors like fatigue would have lower influence on the games, thus resulting in a greater level of equity entertainment. Broadcasters would benefit from our analysis as a better scheduled English Premier League would promote matches scheduled at more convenient time, which would in turn result in increased viewership and revenue. How the topic relates to course material. First of all, the problem requires identifying and considering various constraints and factors impact the schedule, which is a key aspect of scheduling theory. For example, each team plays all other teams both home and away. And second, the distance matrix used in the projects are examples of scheduling with weights, which is a type of weighted scheduling problem discussed in the course. And third, the project aims to use similarity annealing algorithm to optimize the schedule, which is a type of heuristic approach covered in the course. And overall, the project demonstrates how scheduling theory and practice can be applied to real-world problems, which is a key theme of the course. And how the topic extends the course concepts is the first, the project involves additional factors such as team payrolls and cumulative days missed by injury, which extends the concept of scheduling theories learning class. And second, the use of distance matrix that incorporates multiple factors represents an extension of the standard approach in scheduling theory that we learn in class. Third, the use of statistical techniques and methods of data-driven decision making is an extension of what we learned from the course as well. And last but not least, the project extends the concept of scheduling theory beyond traditional manufacturing setting with unique challenges and complexity of sports scheduling. And our proposal is that we aim to analyze the current schedule of EPL and address issues faced by the players, teams, and fans. We will consider the factors such as player well-being, important football matches, and a new seasonal schedule will be created to prioritize player well-being and prevent time conflicts. And the goal is to improve the league's overall experience and ensure its growth and success.
Now, let's document how scheduling is currently done. Some of the key factors that impact the scheduling of games in the Premier League include player availability and injury, national team and international football games, stadium slots, and fan preferences. In recent years, there has been a growing awareness of the importance of player well-being in the scheduling process. This has led to a number of changes, such as the introduction of winter breaks and the reduction of midweek fixtures, aimed at improving the physical and mental health of players. The current system of scheduling games involves placing each club into a pairing grid, which is used to define which dates they will play at home. The scheduler then randomly mixes the teams who are away and at home to determine the matches. The scheduler considers factors such as minimizing travel on days such as New Year's Day and Boxing Day. It makes sure that teams do not have more than 2 consecutive home and away games. And finally, the schedule is manually reviewed to make sure it meets all criteria and verification that is feasible. In December 2020, 40% of professional footballers believe that they play too many games in a season, and 55% of footballers say that an overloaded schedule caused them at least one injury. Despite that season being a peculiar case, with it being the first with a Winter World Cup, these concerns by players are indicative of a larger problem. Players tend to play through minor aches and niggles without much concern. However, with the ramping match load, this can lead to catastrophic injuries. Furthermore, due to the increasing demands on managers with multiple high-intensity matches to plan for in a short period of time, players who have recently returned from injuries are immediately made to play these games. This can all be fixed by reshaping the footballing calendar. By creating a more balanced schedule with athlete welfare primarily in mind, there will be tangible benefits in player longevity and overall quality of games. Now, we will cover what we learned to describe and improve this in the future. We will be discussing the process of creating a weighted distance matrix for scheduling games in the English Premier League. We started by gathering a distance matrix of home stadiums of each of the 20 teams in the Prem, and then we collected data on 4 key metrics for each of the 20 teams, namely the annual payroll for playing staff, represented by A, the cumulative number of games missed, represented by B, the squad value in millions, represented by C, and the average age, represented by D. To create a level playing field, we normalized each value by dividing it by the average. We then created an algorithm for the relative strength value, RSV, using the formula RSV equals 0.4A, plus 0.35C minus 0.15B minus 0.1D. The RSV represents the overall strength of each team. Next, we multiplied each value on the distance matrix by the difference between the away team's RSV and the home team's RSV. This was done to give a weightage to the strength of the teams involved in each match. Finally, we created a weighted distance matrix where both team strength and team distance are considered for scheduling. This matrix takes into account the relative strength of each team and the distance between each home team stadium. The purpose of this weighted distance matrix is to ensure that the scheduling of games is both fair and balanced. By taking into account of both team strength and distance, we aim to create a level playing field for all teams in the Prem. As you can see the collection of all key metrics for each of the teams normalized. And on the far right, you can see the results of the RSV equation. As such, this is the final weighted distance matrix after the results of the difference between the RSVs are multiplied by the actual distances.
Now we'll suggest improvements for this topic. In order to optimize the scheduling process for the English Premier League, we explored two different approaches to solving the problem. The first approach is simulated annealing, which is analogous to the real-world process of annealing metals. This approach is simple to implement and has the ability to escape local minima by sometimes selecting worse solutions. The second approach is taboo search, which has the ability to escape local minima and converges faster compared to simulated annealing. Taboo search avoids revisiting solutions by using a taboo list, which is less sensitive to initial parameters and solutions compared to simulated annealing. However, due to the large neighborhood, the performance of taboo search is slower compared to simulated annealing. Both approaches have their strengths and weaknesses, and the choice between them will depend on the specific needs of the project. Ultimately, our project aims to use a simulated annealing algorithm to optimize the schedule, as it is simple to implement and also allows for the potential to escape local minima. This is an example output schedule for the first 2 weeks. Here you can see an example of our runs for the algorithms. So on the left you can see simulated annealing, and on the right you can see taboo search. As you can see at the start, simulated annealing starts off much more shaky and then before converging, whereas taboo search steadily converges to a solution in many less iterations, although taboo search takes much longer because it is slower in terms of runtime. The relegation/promotion aspect of the league creates a unique challenge when it comes to analyzing the improvement of the schedule generated by our solutions data. Since 3 teams will exit and 3 new teams will enter the competition, comparing total distances by the whole league or by each team to the previous season's data would not provide any real-life benefit. Therefore, we need to evaluate the improvement of the schedule based on other factors, such as reduced travel distance for teams or improved balance of fixtures. Another challenge we faced was obtaining historical data on key statistics, such as squad value, which are dynamically generated. As a result, we had to create our relative strength value, RSV, based on the 22/23 season. This may limit our ability to accurately compare the performance of our solution to previous seasons or other leagues. Despite these challenges, our solution still represents a significant improvement over traditional scheduling methods in sports. By incorporating multiple factors into the distance matrix and using statistical techniques to generate the RSV, we were able to create a more balanced and optimized schedule. Overall, our analysis of improvements highlights the importance of considering unique challenges and complexities when applying scheduling theory to real-world problems. The project's successes can be measured by various key performance indicators, KPIs. Hypothetical KPIs for the project include reducing the number of players in the red zone throughout the season, reducing the number of days missed by injury, and creating closer games throughout the season. Closer games would lead to a reduction in goal difference values and expected goal difference values at the end of the season. The goal difference in the difference between number of goals a team has scored and the number of goals conceded. The expected goal difference is based on the quality of chances generated in a match versus the quality of chances conceded. Both metrics are accumulated throughout the season. By reducing the number of players in the red zone and the number of days missed by injury, teams would have a healthier and more reliable players, which could lead to a better performance on the field. Creating closer games would lead to a more exciting season for fans, as well as more competitive environment for the teams. Overall, these KPIs would be indicative of the project's success and create a more efficient and effective schedule for the league.
Thank you for your time.